students, welcome to the lecture series of electronic measurements and instrumentation subject. My name is TSS Nagapavan Kumar. So, here coming to that, the syllabus of this electronic measurements and instrumentation subject is consisting of Unit 1, Performance Characteristics of Instruments and Meters. Second one, Signal Generators and Wave Analyzers. Third one, Oscilloscopes. Fourth one, Bridges. Fifth one, Transducers. And sixth one, Measurement of Physical Parameters. So what is this subject? So in this subject, the title itself, it is explaining what are the studies we are going to see in this subject. Electronic instrumentations, electronic measurements and its instrumentations. So how to measure different types of electronic component behaviors, different types of characteristics of the electronic equipments we have to measure. For measuring the type of activities, we need some instruments. So what are the measurements we are going to measure from the electronic subject, and what are the instruments we are using in the present day in the field of electronics, and based on that, how to design different types of new types of electronic instruments for measuring the different types of activities like voltage, current, or power, or resistance, or capacitance, or inductance, whatever it may be. So these are all the measurements we are going to study in this subject. So based on this information, the complete syllabus is divided into 6 categories. In the Unit 1, we will see the performance characteristics of instruments. So whichever the instrument, okay, here we have what is a generalized characteristics for the instrument. What is how we can estimate the performance of an instrument. So for estimating the performance of an instrument, we need to see some of the basic characteristics like static and dynamic characteristics. We will see those static and dynamic characteristics in this first unit, and we will see the meters, different types of voltmeters, ammeters, ohm meters, different types of basic analog and digital meters we are going to see in this first unit. Now coming to that second unit. The second unit is signal generators and wave analyzers. In the electronics laboratory, we are using some sinusoidal, triangular and pulse signals. Okay, and here we have some of the analyzers like spectrum analyzers. So these are the different types of instrumentations we have studied from the theory and laboratory subjects. Those instruments, how these instruments are generating signals, these signals behaviors we will see with the second unit syllabus. And coming to the third unit syllabus, oscilloscopes, that is cathode ray oscilloscopes, CROs. From the first year onwards, we are using in our UG level subjects the CRO machine. So in the each and every laboratory of the electronic student is compulsory going to be dealing with this cathode ray oscilloscopes. With the help of cathode ray oscilloscopes, we can visualize different types of signals, different types of functions. So how these functions are appearing on a screen of the CRO, what is the internal structure of the CRO, and how the signals are generating based on the information, how the output wave is varying. These are all the informations we are going to study in the third unit. Now coming to the fourth unit, bridges. The bridge. A bridge circuit we are using for the measuring for the unknown values. In the lot of fields, we have some resistance, inductance, capacitance values. So we don't know the values which will be there in the real time. Those values we have to measure. That is, we have to measure unknown resistance, unknown inductance, and unknown capacitance. With the help of DC and AC bridges, we are measuring the unknown values of RLC parameters by known parameters of some resistances and inductances and capacitors. That is, the unknown component has some resistance. By knowing some known resistance value, we are analyzing the unknown property of the resistance of an instrument. So with the help of bridges, we are measuring unknown RLC parameters. Next, fifth one, transducer. A transducer is a device which converts one form of energy into another form of the energy. Most of the times we are converting the non-electrical energy into electrical energy and vice versa. So here, for example, if the human body is suffering with some problem, we have to measure the problem by the help of transducers. If any human activity will be there, some motion will be there, how to convert the motion into electrical signals. Okay, right. So many type of non-electrical energies like temperature or pressure or velocity or force. These are all the parameters we are converting with the help of these transducers. So we will see different types of transducer and their working functionalities in the 5th chapter. And coming to the last 6th chapter, measurement of physical parameters. For measuring the non-electrical energies like physical parameters, which type of electrical methods we are using and what are the total types of transducers we are using in the field of physical transducers. These are all the informations we will see in the 6th unit. So in this lecture, we will see measurements and instrumentation definitions, and we will see objectives of an instrumentation system in the real time. Okay, let us see the definition of measurement. Right, coming to the definition of measurement. The process of determining the amount, degree or capacity by comparison with the accepted standards of the system being used. So here it's very simple thing. The measurement, what we are doing measurement, when we are taking some milk from the shop, he will give half-liter packet. That is half-liter packet. We are measuring that half-liter packet is consisting of half-liter of milk. No, this is the accepted some company or standards are available by the milk dairies, and their milk dairies are measuring this 500 ml of milk from their containers and they are packing these values and they are giving. So we are getting some of the predefined or pre-measured quantities or products in the shops ready-made, and sometimes we are taking the measurements in the real time. For example, if you are going to a shop and you are asking half kg maida or half kg wheat flour, right? Then they are taking a weighing machine. In that weighing machine, they are placing a paper on the paper. They are putting some rice flour or wheat flour, whichever the flour you require, and they are measuring up to it is getting 500 grams or not, up to it is getting 1000 grams or not. Here we have said that 500 grams, 1000 grams. Grams is nothing but as we are using grams standard unit for measuring the weight, and liters we are using for the measurement of liquids. Okay, so like this we have some accepted standards of units. Okay, so by using some accepted standards of units, we are giving the status of the system. Let us see clearly with one more definition of measurement. The measurement is usually ascertain and present the state, condition or characteristics of a system in quantitative terms. Quantitative terms means weight or maybe liters or maybe volts or maybe ampere or maybe ohms or maybe any type of parameters called quantitative terms. And coming to that, we are presenting the state of the system. Here we are presenting the state of the system. Here we are presenting the state of the system. What is the behavior of the system in the present situation, and what is the condition and what are the characteristics. For example, if you want to measure the speed of a fan, right? Now the fan is there at the ceiling. Now you have not switched on, right? What is the state of the system? The system, the fan is not in the switched on condition. Now the RPM of the fan is equal to 0 RPM. That is, RPM is revolutions per minute. It is not rotating, so we are not we are saying that there are 0 rotations per minute, 0 revolutions per minute. If you switch on the fan is revolving with some speed. Then we will say it is revolving maybe 500 times per minute or 1000 times per minute or 2000 times per minute. Like that we will say. In the bike also we have a special type of meter, speedometer. In the speedometer we can see the wheel rotations, how many number of rotations are moving, revolving by the bike per minute we can see in the bikes also. Otherwise we can see the motor revolutions per minute. Like that we are providing the state of the machine, right? For if you are giving if the low voltage is coming through to our home, then the fan is going to revoluting with very less speed. At that time, how many revolutions are performing by the fan? We are measuring. If you have sufficient voltage, then it will rotate with the maximum revolutions per minute. That is the full of speed. So like that, we are measuring different types of values. That is, we are giving the state of the system. The system is revolving or not. The system has consisting of voltage or not. By using a multimeter, by using a voltmeter, you can say some voltage is there in this wires. Otherwise, we cannot say no voltage is available in that wires. That is based on the availability of the system. If the current is there, we have to say the current is there. How much current is there? We have to give the current in terms of amperes. Like that, we have to define the characteristics of the system. That is very, very important. So what is the use of this measurement? For example, an electrical wire is there. In that electrical wire, some voltage is there. Okay, so we have measured by using a meter, and we said that that electrical wire is consisting of some 230 volts of AC supply. Now, what is the use of knowing this information? If you know that information, some electricity is there in that wire, we are not ready to touch that wire. Right? That means if you know the characteristics of a system, we will decide what we have to do. Okay, with the help of measurement, what we have to do, that we will decide with the help of measurements. It enables the experimenter to understand the state of the system. That means we can understand the system, what is its behavior, which it exists, or to distinguish the transition of the system from one state to another. So what is the present state of the system, and if we want to change from the on state to off state, what we have to do, and if it is not in working condition, then what we have to do? Then we will check the voltage is passing through that electronic equipment. We will check with a tester. Then if any electricity is not passing through the particular system, then we will come to a conclusion. The electricity will not distributing into the particular system. So there may be a power supply failure will be there in that particular system. Then we will go to the power supply section. Then we are going to repair that module. That is, the experimenter enables about that information of the system. So this is the definition of the measurement. Right. Now, for measuring, we need some device like voltmeter, or for like tester, we need some instrument. So now we have to see the definition of instrument. So before going to the definition of instrument, we will see different types of measurements. The first one, direct measurements. Second one, indirect measurements. Direct measurements and indirect measurements are available. Where the direct measurements, by using a voltmeter, you can say this much of voltage is available. By using an ammeter, you can say this much of current is available. By using a weighing machine, you can say this much of weight is there for the products. For example, you are going to a supermarket and you are going to buy some carrot or some vegetables. Okay, by using a weighing machine, you are measuring some weights of the vegetables. But here the problem is that how much money you have. For example, you have 1000 rupees. You have 1000 rupees. For 1000 rupees, how many vegetables will come? Then what we will do, we will take the price of the carrot, we will take the price of the tomatoes, we will take the price of the beans. Like that, whatever the products you required, all the information you have to collect. After collecting all the information from the weighing machines which is available from the supermarket, then you have to add all these costs of these vegetables. Then check what is the total price. The total price is available with you or not, you are checking. So in this way, you are checking the total price and the enough money is available with you or not. That is, you are doing indirect measurements. Okay, so sometimes we are doing direct measurements, sometimes we are doing indirect measurements. Voltage we can get from the electrical wires directly by using a voltmeter. Our current you can get by using ammeter, by using different types of less microamperes based meters or milliamperes ammeter. So with the help of voltmeters, ammeters, you are measuring voltage values and you are measuring current values. Then you have to find the resistance parameter. So for measuring the resistance parameter, now you don't have any equipment. Then what you will do, you have a relationship called Ohm's law, V is equal to IR. By using this expression, you are measuring resistance. And if you want to know the power, then you have to use the power equation. Then you have to know some other more parameters. Then you have to use another expressions. So the measurement which will not give the direct value of that information, that we can measure by using indirect measurements. Some of the parameters we can measure directly, some of the parameters we have to gather the basic parameters, then we have to relate those basic parameters by using some functionalities or by using some standards of equations. Then we can finally say that this is the value. That is indirect measurements we are taking. So this is about the measurements process. Next, coming to that, the definition of instrument. An instrument which is used for measuring the process. Right. An instrument is a device or is a mechanism is used to determine the present value of the quantity under measurement. So whichever the quantity we are measuring, that measurement which type of device is handling, that handling devices we are calling as instrument. Generally, we can define the instrument in this way. An instrument is a device which is used for sensing, which is used for detecting or measuring, recording, multifunctioning, controlling, computing, communicating with a higher accuracy and precision where the measurement is involved. So see here what the instrument will do, the instrument not only going to measure the values, it is also sensing the information, it is also detecting the information, it is using for measuring, recording, that means storing purpose, multifunctioning, it will do multiple operations, controlling, it is controlling other parameters also. An instrument is controlling other parameters also. We are not discussing the definition of measurement, we are discussing the definition of instrument. An instrument can measure, an instrument can sense, an instrument can detect, an instrument can do multifunctioning operations, an instrument can control, an instrument can compute, that means it will compute some mathematical or logical operations. An instrument can communicate, it may be a communication type device with higher accuracy, that means all these operations will be done by with an excellent performance. The performance we are indicating within a higher accuracy or next precision where the measurement involved. Where the measurement is involved in that area, we are doing all these operations with a very high accuracy, otherwise with very good performance. So this is the performance of any instrument, right? Any type of device which is used for this type of operations, that type of device we can call as an instrument. Next. So this is the very important concept, objectives of the instrument, any type of instrument. So how many types of instruments are available? So mechanical instruments are available, some electrical instruments are available, electronic instruments are available. We have a lot of branches of instrumentations. A lot of engineering branches are available in the instrumentations. But majorly these three branches are very important in the concept of instrumentation. One is mechanical, second one electrical, and third one is electronics. What is the objective? What these instruments are doing? What these instruments are doing, right? The first one, it is doing information gathering. So whatever the informations are available in its surroundings, all these informations are gathering with this electronic instruments. By using voltmeter, it is collecting the how much voltage available in the electrical lines. Like that, it will collect the information. So diagnosis. So what is meant by diagnosis? So information gathering. Here the electrical wires are available or not. If you know the electrical wires are available, then you are going to measure the voltage. So what is the how much voltage is there in that particular electrical wire? So it will give some characteristics. So it will give some values. Some 30 volts supply is there. Some 50 volts supply is there. Some 70 volts or plus 230 volts supply is there. Like that, it will measure all the informations. Next one, third one, evaluation. Okay, some supply will be there. Then what we have to do? If supply is there, if the machine is running smoothly, then there is no necessity of doing anything. If is there any less amount of voltages, if you are receiving high amount of voltages, then you have to regulate that voltages. Then you have to regulate the voltages. If less voltages are coming, then you have to do some repairing problem. Then you have to start servicing. Okay, like that we have to evaluate. That means we have to say this is the problem. No, otherwise this is not the problem. Like that we have to get some conclusion. Okay, right. Next one, monitoring. Right, monitoring is very, very important. So you have measured and you have evaluated that problem, but the problem is there for a long time or not. So today morning the problem is there. Today morning at the time of 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 a.m., every 1 hour we have to check the problem is there or not. For that reason, we have to provide some instrument in the field of monitoring. That means we have to measure these values continuously for every 1 hour or for every half an hour or every 15 minutes. Like we have to do the monitoring. That is very, very important. Okay. So you have measured and you have evaluated and you have monitored everything. Now the last one is controlling. So then we have to control. If is there any shock, from that electrical equipment, then we have to control that electricity passing through the human body. How can you control? By providing a proper earthing connection to the ground. That means we have to go and we have to repair that equipment. Otherwise, we have to control that equipment. Right? So these 5 objectives are very, very important in the field of electronic measurements and instrumentation. Okay, these are the 5 arrows to reach the goal of EMI subject. To learn this EMI subject, we need these 5 arrows. Okay, for designing a perfect instrument or designing a perfect theory, we need these 5 objectives in a successful way. Okay, right. Okay, with this we have completed the first lecture of electronic measurements and instrumentation. In the next lecture, we will see the performance characteristics of instrument, like static characteristics and dynamic characteristics. Okay, so the static characteristics when we have to define and the dynamic characteristics when we have to define. Just now we have completed some measuring processes and some instrumentations are available, and we have some of the voltmeters and we have some of the ammeters and we have different types of instruments in our electronics field. And in any branch of engineering, most of the instruments are available priorly. Then what is the use of learning this subject again? For measuring the voltage, voltmeter is available. For measuring the current, ammeter is available. For measuring all the types of activities in the field of electronics, so many instruments are available. For converting the non-electrical energies into the electrical energies, transducers are available. All the types of equipments are available. Then again still, what is the use of learning this subject? Okay, so for any type of subject, we will get this type of doubt. Why? Because already all the types of products are available. Then what is the learning of this subject? You have to remember this information very clearly. That is the first one. There is always a need for improvement and development of new equipment to solve measurement problems. When we are measuring with the voltmeters, ammeters or multimeters or any latest electronic equipment, by using these equipments we are measuring different types of activities. For any type of devices, some drawbacks or limitations are available. Okay, so 100% there is a separate chance or there is a choice or there may be a chance is there to improve the measurement process. Okay, there is always a need is there for improvement or under development for the new equipment to solve the problems which we are facing in the real time. Next coming to that, the second one, the major problem encountered with any measuring instrument is the error. So any type of instrument, it may be very advanced instrument, there may be some errors are available. So it may be static errors or maybe dynamic errors. It may be static error or it may be dynamic error. Different types of errors are available. These errors we have to solve. And now coming to that, the third point, to avoid errors in any experimental work, careful planning, execution and evaluation of the experiments are essential. For avoiding errors, for any type of error, if you want to avoid those type of errors, it is very important. The first one, the experimental work, right? The experimental work is very important, and careful planning is also very important, and execution important, and evaluation important. A perfect way of planning, a perfect way of execution, and a perfect way of taking care. These all are the very important to solve the errors which are facing in the real time. Okay, so we have to learn this subject with a very high amount of concentration. Why? Because these are the different types of very advanced subjects, and these all are the subjects we are gathering, or we are forming or developing from the basics of electronics and instrumentation branch related subjects. Right, with these subjects we can solve or we can provide any type of instrument in the field of electronics to measure or to solve the most of the problems which are facing in the present day generation. Okay, in the next class we will see the concept of performance of characteristics of an instrument, that is static and dynamic characteristics. We will see in the next class. Okay, thank you.